Yeah, it just says it's being recorded.
Sweet. Okay, so we're good to go. Let's wait on Trayden to get back.
Okay.
And as soon as he does, we'll kind of go over some stuff.
Okay. Sounds good. Oh, let me get a highlighter real quick. I'll think about it.
Kyle, what's up? Look at all them cowboy hats.
All right, I got it.
All right. Well, hey, Mark went to grab a highlighter. He'll be right back. Just a second.
All right.
And then we'll get started. Connor, you got your book by chance?
Yeah, I'm gonna go grab it.
Yeah, grab it. All right. So what we're going to be looking at tomorrow in lab. Everybody has the ability now to build that system and get all the equipment hooked up with tubing. What we're going to do tomorrow is we're going to practice like some calibration of equipment. So we'll step through that, and it won't take the whole time. But we're also going to get into the lab where we start to add proportional and see what proportional does to our process. Now, when y'all left off in 1340, where did y'all leave proportional? Like, did y'all just talk about what it does, or that it exists, or what?
We kind of got into like the basics of what it does, kind of.
Okay, so without putting you on the spot, what do you think it does? What's its job? If you need to put it into a scenario, that's fine too. And if you don't have an answer, that's fine. I can.
All Mike did was really give us like a packet of like what a PID controller is, but he didn't really explain like what proportional, integral, or derivative like actually meant.
Okay, so
wouldn't it be like cruise control in the car?
And I mean, it has components of it. It is made up of an algorithm, but the proportional portion of the PID control, like, it has a unique function, right?
Right.
It is, when we give it a value, because right now, if you remember, we build the 6 points in the system. What do you have? What was your value for proportional yesterday in the lab?
0.
It was 0. So think of it as, and I always, give this explanation that 2 + 2 = 4, right? Well, for proportional, like in our equation as of yesterday, we were 0 + 0 = something, right? We didn't give proportional any values. Now,
right.
That being said, they're not additive. So you don't add this one plus this one and it has to equal a number. But that the theory of that equation kind of still works with what we're trying to do. If we wanted our set point to be 9 psi, then if A plus B has to equal C, right, and C always equals 4, then if A is a 2, B has to equal 2. If A is a 3, B has to equal 1, right?
Right.
Because they always, the goal of this process, of this algorithm, the loop statement that we wrote, its job is to make sure that the measured variable equals the set point, right? Like, that's the only thing it's supposed to do, is make the measured variable, which is the pressure, equal to the set point. So if you go into your process tomorrow, into the lab, and you give the set point a value of 9 psi, and you have your program written and everything is ready to go, with the values of 0, 0, and 0, 0 proportional, 0 integral, and 0 derivative, that process is not going to try to start elevating your I to P to go towards 9 PSI. But the moment, here's the thing, that's with zeros in PI and D. The moment that we start putting numbers into PI and D, we start to see the output change in an effort to go towards set point, right? It's trying to make the measured variable equal to set point. So what we're going to do tomorrow is we're going to calibrate that equipment. We're going to calibrate the I to P to where it puts out 3 to 15 PSI. That's the first thing we're going to do. The next thing we're going to do is we're going to calibrate that pressure transmitter so that it monitors and can read 3 to 15 PSI. So then mechanically, all of our equipment will be set up. And the very next thing that we're going to do is we're going to play with proportional. Put values in proportional so that when we put a new value in there, we're going to see the output make an adjustment.
Okay.
Now, there's a term that we use called offset. Some people call it error. Some people call it offset. If you look in the back of the book, there is there's a glossary on page 480. So if you go and you look up, let's go look up error real quick. ERROR. The difference between the actual and the true value, often expressed as a percentage of either span or the upper range value. All right, that's fine. Now let's flip over and let's look at offset on the page 484. Offset is the difference between what we get and what we want. The difference between the point at which the process stabilizes and the instruction introduced into the controller by set point. I like the first part of that definition best, the difference between what we get and what we want. We want 9 PSI. That's our set point. That's the value, the desired value that we want. And when we first start the system up, we have 0 PSI. So the offset is 9. And if we turn the thing on and now the I to P is putting in its minimal value, its 4 milliamp value, which is 3 PSI, our offset moves from 9 PSI to 6 PSI because set point's still 9.
Right.
And now we're pushing 3 PSI into the system so that offset changed from 9 to 6. You with me?
Yeah.
All right. So proportional alone. Okay. This is the thing. And this is one of the main things we have to grasp with proportional. And then we'll get on and talk about integral later. Proportional, integral, and derivative can all work at the same time. They can all do their jobs at the same time as each other in an effort to make the measured variable equal to set point, right? So proportional is almost a canned response. So if I give it a value, if I put 1,000 in proportional tomorrow, I'm going to get a defined amount of additional output to solve however much offset I've got. Proportional only looks at the offset. So if my offset was 9, proportional would make a certain amount of adjustment. If the offset was 6, it would make a smaller percentage of that adjustment. If the offset was 3, it would make a smaller percentage of that adjustment. So
Is that what
you
it
can
means by
make proportional by the value that you put in proportional. You can make the output move a whole lot in an effort to eliminate the offset, or you can make it just move a little bit. But it's looking specifically at how much do you want me to move with this much error, with this much offset? How much do you want me to move? You want me to move a bunch? You want me to move a little? The thing about it is, it's almost like and I do this in air quotes, a one-time shot, because when you have offset, it's a known value, right? Like it's 9 PSI. Right. And if I put a value in there for proportional that is going to make my output increase, and let's just say it dumps 4 PSI worth of air into the tank. Y'all still there?
Yeah, well,
okay.
Yeah, still
So my offset goes from 9 PSI to 5 PSI. Well, there is a there's a given amount of change because there's a new offset. Yes, we went from
Yes.
9 to 5. There's a new offset. Proportional wants to do something about that offset, but it's going to actually do a little bit less than it did last time because the offset's not bigger than 9. So it's
Okay.
actually going to add just a little bit more, and it ultimately will add. It will start to reduce itself. It will reduce the amount of output change because it's not geared to ever bring the measured variable back to set point. That's not its job.
Oh, okay.
Its job
All right.
is like a one-time shot. Like you're this far away. Okay, well let me make this one adjustment, and then let's see if that gets you closer. And it does.
Okay.
Right? It does get it a little bit closer. But then the next change that it sees is, okay, I've got a new offset here, but I'm not going to add a whole lot more output to kind of fix this problem. That's a whole nother deal. That's where integral comes into play, which we'll talk about next time. So
Okay.
we'll play with proportional tomorrow, and what you will see is that when we put values in there, we'll step through all these different numbers. When you put these numbers in there, you're going to see that the output changes and stops changing, and it becomes stagnant until you add another value in there. And we'll play with this, and you'll see these lines, like your output will be doing a flat line, right? And then all of a sudden it'll jump up and it'll do a flat line. And if we change proportional again, it'll jump up and do another flat line. So depending on how much proportional we continue to add to the system, which we don't like, when you tune a system, we're not going to be playing with proportional all the time after we get it figured out. It's like we're going to do that for a while to kind of trial and error and find that number, that magic number that we want, which there are methods in which we'll talk about that. But we're going to try to find that magic number. And then once we find that, we really don't change it anymore because that's the number that's in there that tunes that for the proportional response. Now, on page 295, which is chapter 12 of the book, this is controller adjustments, okay? And inside of here, there's some stuff that I've highlighted. There's some good information in here, right? It's a short chapter, but it's got some pretty good stuff. That first paragraph is very important. All controllers must be adjusted or tuned to accommodate the processes they control. There are several approaches to this task. Some of the techniques are mathematical. However, the most widely used approach is a combination of experience and trial and error. So the mathematical technique that they're talking about, there's a couple of them. There's a closed loop method. There's Ziegler-Nichols, which is a couple of guys got together and figured out this math, this way to do this with math. There's open loop adjustment. There's a few more, right? But the number one most widely used approach is a combination of experience and trial and error. Right now, you have no experience tuning that pressure process. And in about 4 weeks, you're going to have experience and trial and error in how to tune that process. So the numbers that you come up with in 4 weeks will be the result of trial and error and having had some experience built in over the next 4 weeks of how to tune that process. You will see if you need to adjust your proportional or your integral. So we'll play with those values back and forth, starting with proportional tomorrow. We'll play with those values until you can understand what they do, right? Okay. So the next thing that we hit down here on the bottom of 295 is proportional only controller. All controllers are different, right? PLCs, Delta V, the stuff that we're using, everything is, the controllers, they do theoretically the same thing. They just have different ways of doing it. Some controllers, you have to basically turn on a toggle button. Like you need to turn on the ability to do proportional, or you need to turn on the ability to do integral. But for ours, to turn it off, you just add the number, you just put the number 0 in it. So right now, proportional, integral, and derivative are all turned off because they have values of 0. The moment that we put some value in there greater than 0, those things become active. And they start to try to manipulate the output in an effort to get the measured variable to set point, right? The measured variable being pressure of the tank, which is our transmitter monitoring the tank. And the output is our manipulated variable, the I to P, dumping air into the tank, right? So we can control one of those. The other one we're just monitoring. It says down here on page 295, the proportional only controller, in order to determine the dynamic gain, which that is a term we'll get into a little bit deeper. The dynamic gain of a loop exclusive to the controller, the following procedure may be followed with a proportional only controller. So this is a recommendation of them. And then you've got steps 1, 2, 3, 4, 5, and 6. If you look at step number 6. Keep repeating steps 3, 4, and 5 until a constant amplitude cycle is observed. At this condition, the loop has a gain of 1. We're going to do that, and that's not going to mean much to you reading it out of the book, but when you see it in the lab, it will make sense. What we're going to do is we're going to make our process oscillate. And when I say oscillate, I want this. It's going to go up and down. Our output's going to create this wave pattern, right? And for every attempt, think about this. For every attempt we get at solving the equation, which is making the measurement go to set point, we're trying to correct that 6 PSI offset. We're at 3 PSI. Our IDP's, dumping in its minimum value of 3, and we want a set point of 9, so we have an offset of 6. If I put a value in proportional that makes it solve that equation, and we go from 3 PSI up to 9 PSI, and now, because you're going to see this wave happen, you're going to see this wave go like this, right? The beginning of a curve. The offset will have gone to 0. The moment that the offset goes to 0, proportional says, okay, there's no offset in here. I'm going to take back all of the stuff that I put into this process because there's no offset. If there's no offset, I'm not supposed to be doing any work. So it removes all the milliamp signal. It removes all that air from the process. And as soon as it starts removing the air, what happens? The offset goes 9, 8, 7, 6, 5, 4, 3. So now you've got this wave pattern, right? This up and down curve that has been created where we found a gain that is what they call a 1. They refer to that gain as a 1, right? Which ultimately all that means is we have true oscillation where we can get to set point, and the moment we get there, we back away from set point. And you will see this happen tomorrow because we're going to hunt for this number. We're going to try to find this number tomorrow so that we can create oscillation. But one of the other things to notice about this is, there's 6 steps in here, but they go back into step 6. Keep repeating steps 3, 4, and 5 until a constant amplitude cycle is observed. That sounds an awful lot like trial and error to me, right?
Yeah,
so
agreed.
In the book is telling us we're going to trial and error this thing until we figure it out. Repeat the steps 3, 4, and 5 until we get there. I'm just going to teach it to you a different way than the 6 steps that are in the book. Make sense?
Yeah.
All right. So I'm going to, this is a fast forward, this chapter 12. If you want to read through it, it's good. I can make sense of it for you if you want to, but proportional plus integral and then adding derivative, we're not going to get into that just yet.
Okay.
On page 298, there's a thing called a tuning map. Okay.
Yeah, I see that.
This is a very good tool. This is a tool that allows you to see what kind of wave you have. And then if you need to add, increase or decrease integral, or if you need to increase or decrease proportional. So this tuning map is a pretty handy tool. Okay. And you can apply this to the pressure process that we're using. You can make the pressure process work off of this. It's going to tell you by looking at the wave you have. Let's say you had something crazy like the bottom left. It's telling me that for me to straighten that out, I need to increase my proportional, and I also need to increase my integral. And as I move to the right and up, it's going to start to straighten that thing out. Now, I can go too far, like the one in the top right. I have increased my proportional too much, and I've increased my integral too much, and we've got that issue. So based on this chart, this will kind of help you navigate roughly which direction you need to go. Of course, you can always trial and error it too, just plugging in numbers and seeing what happens, right? That's the beauty of running that charting software, because the charting software can basically have all that information laid out for you. If you watch the clock, if you watch the timer and say, okay, at 8:45, I changed the value to this, this is what I would recommend, getting a notebook. And every time you change proportional, integral, and derivative, you make an adjustment you'd make a note on a line of piece of paper in a notebook pad and say, this is what I changed it from, this is what I changed it to, and then if the result was good or bad, you can just put a check mark or put an X by it. If it was an increase or a positive adjustment, or if it was a negative adjustment, you could put that in there.
Okay.
Over on page 300, this chart, this is also a very good chart, okay? Some systems, think of it as chocolate and vanilla, right? Those are the two flavors of ice cream you get. They're both ice cream, yes?
Right.
So you get proportional band in percent, or you get gain. You get one or the other. They ultimately are the same exact thing. However, they're reciprocals of each other.
Okay.
Some controllers use proportional band in percent. Some controllers use the term gain. So you would have to increase your number to see a larger response in your output in some controllers, and then in the other controllers you'd have to decrease your proportional to see or increase your gain, whichever. But you would have to go the opposite direction because they don't have proportional band, they got gain. They don't have gain, they got proportional band. You would go the opposite direction. Like a smaller number is going to give you more response. And
Okay. Yeah, I see that here.
Instead of 1, you'd be 0.5, 0.25, 0.1, 0.09. The smaller you adjust that number, the larger change you may get in your output. That is, gain and proportional band in percent are the exact same thing. However, they are reciprocals of each other, and it depends on what controller you're using. That's what's going to tell you whether or not you have to increase or decrease that number to get the response.
Okay.
And you're not going to do it until you're working on that equipment. You won't know that because you could go and research, try to find out what if a controller uses gain or proportional band in percent. Good luck. Go try to find it. And you're not going to know that until you actually have that piece of equipment on an output and you see that you've made the change and it either positively affected the output and got you closer to set point, or it negatively affected it and drove you further from set point, right? That's the trial and error part.
Right.
So that's going to be one of the things that you're going to end up finding out. All right. That kind of does it for the stuff I want to discuss in chapter 12. But if you want to, you can read through there. You got questions, feel free to, and I would recommend reading the chapter, right? Because if you have a little bit of that information going into tomorrow, then it's going to make the lab make more sense. If you don't have that information, you're going to go into lab, you're going to do the same thing we're going to do in lab tomorrow also, but you won't have any of this background information. And this background information is going to be helpful because you're going to have an insight on how to tune these things. Any questions?
So we're not going to go over the closed loop cycling method?
Not right now. We're gonna just figure out what proportional does tomorrow.
Okay, that sounds good.
When are we looking for like our first test and stuff?
All right, good question. So if you'll flip to the front of the book, there's a contents page on it's called page number V, page 5, I guess. So look at the table of contents in the front. Got it?
Yeah.
Okay. So here's what we need to cover, right? This is material that's in the videos. If you haven't watched the videos, you need to get on them. Section 1, which is feedback process control, which is going to be chapter 1, introduction to process control. Number 2, which is pressure measurements. Number 3, which is level measurement. Number 4, which is flow measurement. And number 5, which is temperature and humidity measurement. That's a lot of stuff. Now, those chapters, here's what they cover. They cover how to choose and how to apply what transmitters, like what you're trying to monitor. And if you're monitoring a certain process, why you would select this version of sensor as opposed to that version of sensor.
Okay.
Right?
That makes sense.
Why would you choose if you've got something that's I don't say turbulent, but like that's dirty and has a lot of debris in it. Let's just go with an airstream for that, for an example. If I've got something that has a lot of particulate in it, right? So think of a cotton
Right.
gin, think of something where there's a lot of dirty air because it's got a lot of stuff flying around in the air, and you're still
Like for lesser plant or
no, because something that has particulate in it, right?
oh, okay.
Think about small, grains of dust.
Oh, okay. All right.
Over time, that dust will start to settle, right? And if it settles inside of a sensor that has small ports, that sensor will no longer read anything. So there may be a better way to monitor. There may be a better sensor to put in there than what we call a pitot tube. There may be a better sensor that we could install that would mean less maintenance, that may be a little bit more expensive, but would give us long-term benefits by being accurate over time. Those chapters go over the sensors for the four main processes that we monitor at TSTC and in this field in general, right? Pressure, level, flow, and temperature. Those are the four big ones, okay? There's tons of other ones, but those are the four most popular.
Okay.
Those chapters, chapter 2, 3, 4, and 5, go over where do I mount this device? What kind of device do I mount? How does this device work? And if we can understand how those are installed, how they actually do monitor, if it's resistance, if it's an armature that is changing, if it's a diaphragm, if it's two plates like inductive, it's an induced voltage by two plates being closer together or farther apart. Those things are how some of these sensors are built, and it goes over that in those chapters. Now, in the back of each chapter, there is a quiz. It's nothing more than it's basically questions for every chapter. Those answers are in the back of the book. So the back of chapter 1 has, on page 488, it has the answers to the questions.
Okay.
Right? You got
Right.
question 1 through question 15, and it's got the answers there on page 488. I don't want you to just memorize these answers because that would be something that would be easy to do.
Yep.
The thing that's going to serve you better is to go into the book, read the question, and then go try to find the answer in the chapter.
Yep.
Right? Because somewhere in there, like there's a reason why that answer is what it is. Go in there and find what it is. And I'll give you an example of that. If I go to page, let's see here. Excuse me. If I go to page 30, question 1, all control systems that fit into the usual pattern are, I know that the answer is C, closed loop, but more importantly, I know that that answer comes from page 29. So if I flip back to page 29, I know that that answer is on that page, and I can go and find that and highlight that information in there.
Okay.
This is how you can get more out of this book. Just
Okay.
going through and trying to memorize the questions at the back and the answers is not going to make you the best technician that graduates whenever it is
Right.
y'all graduate.
Exactly.
Knowing this
Exactly.
information and understanding it from the book is going to be better. Yes, sir.
So I've already done that, but
Good.
so you want us to memorize to find like
The question is not going to be what page does that come off of, and the question is not going to be all control systems that fit into a usual pattern are closed loop. I want you to understand why it is closed loop.
Okay.
Why is it not open loop? Why is it not on off? And why is it not a non-self-regulating loop?
Okay.
Yeah, because I did the same thing with the
Those
questions.
are the things that you need to be able to figure out. And that's what's going to make you above all the other students in the class, right? Which I want every one of you to do that. But the reality is there is a hierarchy of how this is going to be graded. And your grade needs to be the highest. And this is how you get there because you're going to understand this stuff on a different level than everybody else, right?
Okay.
So one, just participating in these conversations will do that. Do you have on page 65? Go to page 65.
Okay, I'm there.
What page does that question number 2-1? What page does that come off of?
2-1.
40. I got it marked as 47.
Good. Okay, so on page 47, there should be an explanation on exactly how you figure out how to get the minimum max values
Mhm.
Yep.
to answer that question. So I'm going to give you different numbers to that equation. I'll give you different numbers, but you already know how to do that because you figured it out on page 247.
Okay.
That's how this is going to be shaped. All right.
That sounds
that's all I
good.
got for today. Y'all got any questions for me?
No,
I'm good.
no questions at all.
Nothing? Trading?
Nope, I'm good.
All right, fellas. We'll see y'all in the morning.
Yep.
All right, sounds
Later.
good.
Bye.